Hello, most of you are actually performing overdesign on your columns when you're using this software, and without even knowing, you are designing more reinforcement or using more reinforcement for your structure than what is actually required. And most times when you compare it to other softwares, that this one is giving overdesign, but that's because you are not actually inputting the right factor which you're meant to use when you're designing for your columns. There is what they call overstrength factor when it comes to column design, even in manual design and also in software. There's what they call reinforcement over strength factor, and this factor actually ranges from 0.87 to 1.25. Now, within this range of value, you are meant to choose according to the structure you are designing for. If you're designing for a minor structure, then you are meant to use what? You are meant to use a lower range of value. And if you're designing for a higher or a structure that will depend solely on the column when it comes to capacity design, then you can choose average or a higher value. Okay, that is fine. So in this video, I'll be showing you all that. Now, this building you're seeing here on my screen is a real life building or project we are designing for. As you can see, the architectural model here. So this is the architectural model which you can see here. So this is the roof, as you can see the roof step down there and that. And then this is a hostel building. Basically it's 60 meters long by 40 something meters width. Okay, it's a very massive structure. Yeah, and you can see the plan view here. This is the plan view, or you can see that this is a hostel structure. Yeah, and this is the first floor building, the first floor building plan, which you can see here too. It's also a hostel structure. So this is actually a real life design we are performing. And then in the course of that, I said, okay, so it would be nice to use this building to like show you guys how to avoid having excessive reinforcement either on the upper structure or on the lower structure, or having more reinforcement than what is meant to use for your column. And most settings can actually affect this. I say again that most times don't depend on, in fact not most times, don't depend on the defaults that the software is giving you. Always work according to your code standard. That is why manual experience and manual design is actually required before you can be able to begin to use software. Okay, that is fine. So in this case now, once you're done modeling, as you can see now, we are done modeling all our structure, as you can see that, and everything. We are done modeling both the DPC beams, and everything is here modeled. Now the next thing now we are going to move on to is now begin to do what? Perform the structural analysis and design. Now before, I can see that nothing has been done yet, so before I proceed to that, the first thing I'll do is to go and change most of my settings, okay, which I've already changed, but I'll just show you a few of them that are where I made some changes. Okay, that is fine. So in this case now, if you don't want your columns to have excessive reinforcement, if you're designing for a non-complex structure, for example, it is not a high-rise building that the column is the major is the major member to carry the load. What you do, for example, if you're doing for a 1-story or 2-story, or for a less structure that is not complicated, then you have to go under the settings here and change your overstrength factor for your reinforcement on your column. So where do you go? Go to the column tab here on this place here. Now you will see it that says reinforcement over strength factor. At default it is always 1.25. okay, that is fine. So what, and you can see that it has a range of 0.87 to 1.25. This 1.25 is a severe, like is a strict, is a very stiff. If you choose this, if you leave it as this, you'll be having heavy reinforcement. So what you do then, come here and change. So in this case now I'll be using 0.9 because I have a range of 0.87. so any value you are putting here must not be lower than this and must not be higher than this. Okay, so I'll put 0.9 as my value, and I'll come here and do a click on what okay here. Now once I've done this now, I'll come here and do a save. Okay, that is fine. So once I'm done saving now, the next place again you have to go and modify is your stiffness factors for your columns, for your beams, and for your slab. Most of you only modify just the slab and leave the column and the beam. Okay, so to do that now, come to your analysis tab here, and then hold on for a while for that to display. Now once that displays, go to your model option here, and then now on this place, watch, make sure you choose, yeah, don't leave it as none, else it will be too stiff. So make sure you come here and choose either 25 or 50%. okay, any of that is okay. Don't use maximum, and so you can choose any of this, it is okay. Okay, that is fine. Okay, then you now come here under material and stiffness factor, click on this place now, and then hold on for a while. Now once this display, you can see that on my own I've already modified all these values, as you can see that. Else before it used to show this place here as 11111, but But since I'm using Eurocode says that for the walls 0.5 is the stiffness and not 1, and for the beams, sorry, for the slab you can choose to use 0.33 or 0.225. Let me use 0.3. Then for the columns now you are meant to leave it at 0.7. Change from 1.0 to 0.7, and for the beams 0.35 according to Eurocode. Okay, that's fine. This place normally what engineers normally use as conventional is in 0.25. Okay, conventional, but 0.3 is not too bad. Now once you've done all this, now come here and then do what, click on what, okay. Now once you've done this, now you will see that your structural design will begin to behave like what, like as if you just use a manual design. That's because when you're doing a manual design, you like govern yourself more on what the code is saying. You always have your code by your side before you can make any decision. The same thing on when you're using the software. Before you take any decision, you have to do what? Refer back to the code standard. Now all the code has already been implemented on this software, but you have to make your choice now and then choose the appropriate decision for like that. So in that course, now since I've done with that, I can then proceed now to go and run my what, structural analysis and design. Okay, that is fine. So in this case now, I will then proceed to here and then click on this place now, and then click on analysis here, and then click on here, and then click on. So once you've done this now, you will see that now I have steel on the model. Yeah, this building was not modeled with steel before, but later I was called that it is going to be used. It is going to use a steel roof, so I have to model a steel. So in that course now, since we have a steel roof now, I'll have to now go back and then add steel loading. Okay, under my loading combination. Okay, that's fine. So as you can see right now, we don't have steel combination here. So I'll come here and then just include a steel combination on my design here. Okay, that is fine. And I'll just say okay here. So on that now, if you can see now, we now have a steel combination added. Okay, that is fine. So on doing that, I can then come back to my analysis here and then click back on my building analysis and then modify this. Now, the reason for this video is not just to show you how to analyze, but to show you that strength factor. So make sure you change that strength factor before you can begin your analysis and design for any structure. Make sure you reduce that to 0.87 or 0.9 or 1.0, but not 1.25. But this is not the purpose for this video. The purpose of this video was to show you how that you must set that overstrength factor. Okay, that is fine. So make sure you set that whenever you're doing or before you can begin your analysis. Okay, that is fine. But warning, if you are designing for a flat slab, make sure you leave it at 1.25 because knowing that for a flat slab, the column is the most capacity member that we need, all right, to like design, because the column is carrying everything. So make sure you don't touch anything on that strength factor for a flat slab design. Okay, but for other structure, for example beam system, you can do it. Okay, that is fine. Now there is a flat slab masterclass that is coming up, which is a real life project, and it runs all through the month of June. Throughout the weekends of June, it is running. You can get the link down below the description. You can register for that. We have only 10 slot left. You can register for that and then get a detailed training on flat slab design without column drop, and it consists of flat slab analysis. First of all, the modeling, analysis, design, and detailing in AutoCAD. So this is what you are going to learn throughout the month of June, and it only runs for 1 month, all the weekends of June. Okay, that is fine. So you can get that and then enroll for that. Now I'll be showing you on this video again. Next video we are going to upload, I'll be showing you the reason why your plane beam fails when you are using this software to design for your plane beams. Okay, that is because you are applying soil properties on your plane beam, knowing that plane beam is not affected by the soil, it is above the soil, right? So but you are applying soil pressure without you knowing. So the software is seeing the plane beam as a foundation beam, like a ground beam, not just a plane beam. So tomorrow I'll be showing you on that. As you can see on my plane beam here, I'm using 300 and it is still passing. That's because I have already told the software that this is a plane beam and not a ground beam, because knowing that plane beam are found under story 0, so the software sees everything under story 0 as a foundation member or foundation beam. But plane beam is not actually a foundation ground beam, but just a plane beam to carry the like the block wall load around the ground floor region. Okay, that is fine. So see you on the next video, and see you on the upcoming masterclass that starts from June 1st for flat slab. Thank you, and then bye for now. If this video finds you well, please click on the like button and also subscribe to our channel if you're not. Thank you, and bye for now. Bye then, yeah.